good to be back with you. Today I've got to talk about statics, and I want to talk about couples and their moments. Now maybe that's kind of a silly title, but couples and moments are a really important part of statics, okay? Now a moment is a force acting at a distance that makes an object twist, and a couple is just two forces that are equal and opposite interacting parallel to one another, okay? And you can replace a couple with a moment. That's the big idea here. And I've got a simple sample problem here. I've got a beam, and I guess I don't have a length here. It's 3 meters, okay? You can make it 3 feet if that makes you feel better. The problem will work out the same. And so I've got it divided into 3 equal parts. So 1 meter, 1 meter, and 1 meter. And at 1 meter and at 2 meters from the left end, which I've got labeled A, I've got 1,000 newtons down 1 meter over and 1,000 newtons up 2 meters over, right? So remember, GFSA format, given, find, solution, answer. Well, here I'm given all this stuff. Okay, find. Well, what is it that I want to find? How will I know when I'm done? Well, I'm done when I know what FA and FB are. When I got those, I'm done. So let's start with the solution here. Now, there's 2 ways to do this. Okay, well, there's probably more than 2 ways, but I'm going to show you 2 ways to do this. The first is to just leave it exactly like it is, right? Let's go through that real quick. Well, I'm going to write the equations of equilibrium. Okay? Remember, statics, there's not much theory to statics. Some of the forces equal 0, some of the moments equal 0, and you can't push a rope. That's it. The rest is detail, but the details are important. Right, so equations of equilibrium, those are the equations that tell us that whatever's going on here, that structure's not moving. If it was moving, it wouldn't be statics, okay? Then it's a dynamics problem, but this is statics, okay? So the first thing I know is that the sum of the forces in the vertical direction, that's y, is going to be 0. Now if I'm going to write y, obviously I have to have a coordinate system, so I'm going to use the one I normally use. Okay, that's the positive sign convention. X goes to the right, Y goes up, and positive moment goes counterclockwise, right? So sum of the forces in the vertical direction equals 0. Now remember, there's no sum of the forces in the horizontal direction because there aren't any forces in the horizontal direction. Go ahead and write it if you want, but you're going to get 0 equals 0. So I'm about ready to make a mistake here. Have I drawn a free body diagram? I have not. So let's... caught myself. So let's do this real quick. All right. So FA, I'm going to assume that's up, and I'm going to assume that's down over here. If I'm wrong, the signs will come out negative. That's just the math's way of telling me I messed up. That's okay. All right. The math will take care of me. So I've got 100,000 newtons there and 1,000 newtons there. Now I've got, oops, 1,000. Now I've got the free body diagram. Okay, that's good. If you're not drawing a free body diagram and you're doing a statics problem, something's wrong here. So let's do the first of the equations of equilibrium. Equilibrium. Okay, got it. Now I'm in business. Sum of the forces in the y direction equals 0. So what's that mean? Well, anything up is positive, anything down is negative, because that's what my sign convention here says. So let's just go from left to right and let's just do what the math says to do. So FA is positive minus 1,000 newtons there plus 1,000 newtons there minus FB. And all that stuff has to equal 0. Well, okay, those two cancel out. So 0 equals FA minus FB, or FA equals FB. Okay, well that's pretty easy. So I got that. Now, but I still don't know what FA and FB are. Now there's 2 things I don't know, FA and FB. So if there's 2 things I don't know, I must need 2 equations. Well, there's one of them. The other one is the sum of the moments. Now I got to sum the moments around somewhere. How about if I sum the moments around either A or B? That way the resulting equation will only have one unknown in it. Well, just for, I don't know why, let's just solve the sum of the moments about A and make that equal to 0. Okay, it'll work just as well if you sum the moments around B. Mathematically, it doesn't matter. You'll get the same answer either way. So let's see, I've got minus 1 meter, which is that distance right there, times 1,000 newtons, okay, which is that force right there, plus, okay, now minus because that's rotating clockwise about point A. This is going to try to rotate counterclockwise around point A, so that's going to be a positive moment. So that's going to be 2 meters times 1,000 newtons. And I've got 3 meters out to B. Well, let's see, I assume B is down. That'll give me a negative moment. So minus 3 meters times FB. Okay, get out of your way here so you can see all that. Well, let's see, what can I do here? I can combine all that, and I'm going to get, let's see, 1,000 Newton meters minus 3 meters times FB, and that all equals 0. All right, so if I solve that, I'm going to wind up with, well, let me go one more step here. I can get 1,000 Newton meters equals 3 meters times FB. Okay, I'm going to keep that in frame here. Ooh, just barely. Okay, well, meters can cancel out. Okay, units can cancel out just like numbers can. And what I'm going to wind up with is FB equals 1,000 over 3 newtons. It's not a very good line. 1,000 over 3 newtons, and I'll draw a line under that. Hopefully I kept that in frame. Man, just barely. Okay, so I got it. There we go. And so if that's FB, I know FB equals FA. FA must be the same thing. Okay, there's the answer. But I haven't done anything with couples and moments yet. That's because I can do this a second way that might make it maybe easier, but certainly different and equivalent. Okay, let me erase this while I'm talking. One of the things you'll see us do a lot, us being professors and you being students, I guess, in statics and strength of materials is we'll spend a lot of time taking problems we don't know how to solve, turning them into equivalent problems we do know how to solve. And this might be one of those times. Well, I've got that right there, okay? I actually know how to solve this, but that's a couple. I can replace this with a moment. And what I can do is I can shift that force any place I want as long as I account for the shift and include a moment. So what I can do is I can draw this same beam here, and let's see, I'm going to make sure I do this right, okay. So here's my free body diagram again, but I'm going to make one change. I'm going to shift this force over to the center. And what I'm going to do is at the very center, I'm going to replace that with 1,000 newtons, okay, which is the same as I had before, but I'm going to replace it with add a moment to account for the fact that I moved this over. All right. Now this distance right here is 0.5 meters from there to there. My old drafting teacher would kill me for doing that, but there you go. All right. So I've got 500 Newton meters. All right. Well, I'm going to do the same thing to this. I'm going to shift this over as well, that same half a meter. And so now I'm going to get 1,000 newtons down. Okay, and I don't know how to do this. I'll add another, I don't know if this is kosher or not, but okay, there. I'm not sure that's officially approved, but there you go. And what that's going to work out to, keep it in frame, okay. FB, FA, and right there I got 1,000 Newton meters. Okay? This is a much simpler looking problem now. Okay? And it's mathematically equivalent to that original problem. All I did was take the forces, shift them, leave the forces, but add the moment right there to account for the fact that I've shifted them. What I've got right now is 1,000 up and 1,000 down acting at the same point. Well, 1,000 up, 1,000 down, I had it there as well. I'm left here with a moment of 1,000 Newton meters. Well, that's 1 meter from there to there. If I sum the moments about that point, I get 1,000 Newton meters. Makes sense? Right. So if I go through and solve this exact problem, guess what I'm going to find out? I'm going to let you do it because I want to keep this video short. I'm going to find out FA equals FB, just like before. And I'm going to find out that that's 1,000 over 3 newtons. Okay? So there you go. A couple. Okay? There's a couple right there, replaced by a moment. And it's mathematically equivalent because I get the same answer this way as I did when I solved the problem that way. Let me get out of your way one more time here. So there you go, couples and moments. You can take a problem that's maybe a little complicated, turn it into one that's a little less complicated, transform something you're not comfortable with to something you are comfortable with. I hope this helps, and I'll see you next time.